So now what we're going to do is take those different situations in and do a fatigue damage test calculation on it. So to do that, we'll click on New Test and we'll pick fatigue damage. And that brings us right to the Import tab. And we're going to bring more than just one file in. So we go to the FDS Combine tab and select Add Items. Now when we select Add Items, it opens up a file selection mode, and what we can do is go to a recent folder, and I'm going to pick this folder because it has all the files in. Here is a particular case study in the red Mustang with the count them 9 files, and we're going to pick all 9 of those files. Just click on the top one, hold down the shift key, click on the bottom one, or do a control A, whatever your favorite method is to pick all of them, and we're going to bring them in. Now before we bring them in, I need to take a look at which channels are on this one, and notice that this one has XYZ1, XYZ2. As mentioned earlier, we got a input Excel which is mounted on the angle bracket, and a response Excel. We're interested primarily in the input Excel, so we're going to take each one of those in individually. So let's open those and bring those in, and that gives us 9 Excels, or 8 Excels. There they are, 9 of them. And the first one is 8th Avenue X. The second one is 32nd Avenue X. So we have all 9 X channels brought into the system. Now we need to add the Y and the Z of channel 1 also. So let's add items. Pick all of them again, and pick channel Y on the first Excel, the input Excel, and bring those in. Now we have a total of 18. And lastly, we will bring in the Z. So here's our Excels again. Pick all of them and find the Z channel and bring them in. So now we have all 27 inputs. And what we want to do is X, Y, and Z of those 9 conditions. We want to find the highest of X, or the highest of Y, or the highest of Z. And we have this combine method. It has 3 different methods in it. Sum would simply be sum X, sum Y, and sum Z, as in add them together. And if I pick that method, you can see that I get a recording time and a target time for each one. And of course, they are the recording times for each X, Y, and Z. Notice that they're the same, and that's true for all of the 9 situations. It was one recording, X, Y, and Z. And the target lives, of course, are the same. So I could sum them all together, but that's not what I want to do. What I want to do is look at each situation and envelope them. In other words, find out what is the highest of X, what is the highest of Y, and what is the highest of Z, and just use that one, and use that to perhaps create a test or look at the worst case situation of that particular road condition. That would be the envelope. And then there's another one that's cleverly called the per file envelope. And what that's going to do is look at each file, and if the name is the same, it assumes that it's the same situation, and of course the time will be the same too. And if I pick that, now I can combine all of these situations, and the software automatically picks X, Y, and Z, the highest of those, and does a calculation on that, and then X, Y, and Z of the second situation, etc., doing a separate calculation, picking the highest one out of all of them. And you can get the indication that that's happening because the recording time and the target time are the same, and they're blanked out in the other copied channels. So what we're going to do is set our M to be 4, which, by the way, is about the most fatiguing M that you can have. If you don't know what your M is going to be, you might just start with 4. You can play with it and compare them. The Q we'll just leave at 10. And the Q, because we're assuming there might be a resonance at a particular situation, the exact Q doesn't make that much difference in the calculation. It'll smooth it out. It will make more resonances appear more pronounced if the Q is higher versus as it's lower. But Q of 10 or something, whatever your favorite number is, 10 seems to work well. And then we're going to do our analysis from 6 to 2000 hertz at 1/24th of an octave. So each one of these waveforms, we're calculating damage with the SN slope at 4 and running them through the calculator. So here we do, we scan the items and it brings them in. Notice that there's 27 of them. It's working on 4 of 27 now, 5 of 27, and scanning each one in and bringing us to the calculation of fatigue. And it's doing it for X, for Y, and for Z. And as soon as it's finished bringing them all in, running them through pretty high computational, complex, and intensive calculation, but rapidly running them through to come up with a damage for each one of them, and then picking the highest of X, Y, and Z. And here they are. And we can highlight each one. There is X, there is Y, and there is Z of situation 8th Avenue. And what it has done is pick the highest of those three and brought that to the top. And then it does the same thing with this one, X, Y, and Z. They're all shown so you can look at them and see what you think about them, X, Y, and Z. But it actually is picking just the highest of X, Y, or Z, or the highest at each frequency of these same file situations, in adding that to the sum. So what we have is 9 different road conditions, and the total time of all 9 of those is 13 minutes and 15.9 seconds. And our test duration is the same. That's because it automatically made recording duration and target life the same. Now, the target life we really want to put in, maybe it sees the first condition for 1,000 hours, so I can put 1,000 H, hit the tab, puts in 1,000 hours. If the target life really is that for this first situation, look what it did. Cranks it way up here. You can see that each one is significantly higher now. And you can see that the sum line, which is the combined line, is up above them. And you can notice that it brought all of them from down here way up here for situation 1, because what I'm saying is, well, it's really going to see that for 1,000 hours and these only for a minute. Obviously, they're almost inconsequential at that time. But what we're going to do is make all the target lives assimilate what the actual life is, and we'll bring them up. So let's just make them all 500 hours and make them the same. So basically I can 500, I forgot to press the H, 500H, so now I got 500 hours. I'm going to copy that and I'm going to bring it down and paste it in each one. And I'm doing it for the case of simplicity so that I just have to remember that each one is 500 hours. And when we do the second Mustang, I'm going to do the same thing. We're going to make them 500 hours. So we have these same situations, put 500 hours in for each one, and then come up with a total damage for each one. So you can see that now that I've put 500 hours in, it comes up and it says run this profile that is 0.3014 G's RMS. And if you run that for 4,500 hours, that will be the life of your product. And that here is what your acceleration profile will look like. Back to the damage world, and that's what it looks like. Now this is outside the scope of what we want to do, but just a quick comment. Typically you would maybe want to run this for 5 hours. So instead of 0.3 G's, you're going to see that it looks at the M and the Q and says, okay, run it at 1.6 G's for 5 hours. That will give you the same amount of fatigue as all these individual ones summed up. But in our case, we are interested in the fatigue damage of 500 hours of each situation.